Hi students, good evening everyone, and welcome to the evening session. So today we are going to continue our chapter, that is sets. So yesterday we have already gone through some concepts. So today also we are going to continue with that, and I feel all of you have understood the yesterday's concepts, and now we can continue the concepts where we have left from yesterday. So good evening to everyone. I think all of you had your coffee, tea, breakfast, everything, and now we shall just concentrate on the concepts that we are studying. Okay, so with that we can understand more and more concepts. Clear? Okay, so let us go through different types of sets. Let us go through different types of sets. So before that, so yesterday we have studied this problem. Okay, so now let us go through the different types of sets. So first one is null set. First one is null set. So everything know null set. What is null set? Quickly tell me everyone, what is null set? And second one is singleton set, and everyone also know what is singleton set. Null set means which has no elements is called null set, and singleton set means which has only one element is called singleton set. Finite and infinite. Finite means where the counting is going to be possible. If the counting is possible or the counting ends, we say it is finite. If counting not ends, it is called as infinite. Next is equivalent sets, equal sets, subset and superset, proper subset, universal set, and comparability of sets. Okay, so these are called the different types of sets. These are called the different types of sets. So now we can go one by one. What is empty set? A set which has no elements. So you can see that a set, okay, here I will write a set which has no elements. A set which has no elements, okay, and it is represented by, and it is represented by with empty braces or this pi. Okay, don't write like this. Note that this is not used. That means this is not empty set. Clear? So for empty we don't write this. Either you write with empty braces or you write with pi. Don't write like this. It is not empty. Okay, this is not an empty set representation. It is not an empty set representation. Okay, so if you want to say it is empty set, and if you want to represent it, either you can represent it with empty braces or you can represent it with pi. Clear? So this is all about the empty set. So now I want to know, give me the examples. Quickly give me the examples. Examples for empty set. Everyone knows what is empty set, but only few knows to write the definition when it is given. So now I want to know how many of you can give me the example for empty set. Quickly tell me. What will be the example for empty set? Okay, so I want to see how many of you can give the example. So quickly I will see how many of you can give the example. Clear? Okay, next, by looking at the example of empty set, we can go for singleton set. We can go for singleton set. Clear? Okay, so everyone quickly give me example for empty set. Okay, So still I have not got any example. Let it be. So the definition of empty set is set which has no elements. No problem. That is the definition. Now you want example. Now I want example. So see here, I can write example as set of x such that x is lesser than 1 and x belongs to natural number set. X is lesser than 1 and x belongs to natural number set. Okay. So now here you can just see that x has to be lesser than 1 and x has to be natural number, means there are no elements such that which is lesser than 1 and it is natural number. So therefore it is empty. Therefore it is empty. Clear? So like this you can give what examples of empty set, no problem. And you also write no problem like this, x such that x is in between 3 and 4 comma x belongs to integers. X is in between 3 and 4 and x belongs to integers. Okay. So like this also you can write. That means what it tells, x such that x should be greater than 3 and lesser than 4. X should be greater than 3 and lesser than 4 and x must be integer. So you can see on the real number line, this is 0, this is 1, this is 2, this is 3 and this will be 4. But here you can just see, here you have only the rationals and irrationals in between 3 and 4. So in between 3 and 4 no integers are present. In between 3 and 4 no integers are present. Therefore it is also going to be equal to empty set. It is also going to be equal to empty set. Clear? So now we can go for the next type of set, that is singleton set. Okay, a set which contains a set which has only one element. A set which has only one element is called singleton set, or you can say a set which has one element is called singleton set. Clear? So all these definitions are very simple, but here you must practice to give the examples on your own. That means you have to think and give the examples. That is important. So quickly tell me the examples for a singleton set. Clear? So I'll write it as set x such that x is a even prime number. X is a even prime number. All of you has to give the example other than this. The example what I have written, other than that you have to write. Okay. So here I will write example as x such that x is a even prime number, because all of we know that the even prime is only 2. That means it will be equal to 2. Okay, set which has 2. Okay. So therefore it is singleton set because it has only one element. So give me the example other than what I have given. You have to give the example other than that example which I have already written on your screens. Okay. So try to give. I want to see how many of you are thinking about the problem. So next I can write x such that, again same, x is greater than 3, lesser than 5, comma x belongs to natural number comma x belongs to natural number. Like this I can write. Clear? So Sudha and Neha have given two examples that x belongs to odd numbers lesser than 1. So Sudha, check your example. Odd numbers lesser than 1 means, see here, -3 is also odd, -1 is also odd, 0 is also odd. So therefore it is not going to be singleton set. So Neha has given that x such that x belongs to natural numbers lesser than 2. Okay, that is correct. But Sudha, you have to check your example, that is x belongs a odd number lesser than 1, odd numbers lesser than 1, there are so many odd numbers lesser than 1, these all are the odd numbers lesser than 1. Okay, so Sushma has given that x such that x belongs to real number greater than 10. So x belongs to real number greater than 10, there are so many numbers. Okay, x belongs to real number. See, x belongs to real numbers greater than 10 means you can see that greater than 10 there is 11, 12, 13 and all naturals greater than 10, all integers greater than 10, all rationals greater than 10, all irrationals greater than 10, all these are the real numbers. Are you getting my point? So that is also not right. Clear? Okay. So now I think you have to correct yourself, your examples. Okay, very good. Some of you have tried. Let it be. It is right or wrong. You must give the example. You must think. That is what all about your preparation of mains exam or any competitive exam. Here how much you think, that is important. Okay, so this is process of learning. You can give wrong examples, you can give right examples, it doesn't matters, but you have to think and you have to give the examples. Okay, very good. So I think Yuvraj can also give one example. Clear? So try to give an example, Yuvraj, for singleton set as well as empty set. Yuvraj Chauhan, give an example for singleton set as well as empty set. Think and try it. Okay. Next, let us go for finite and infinite. See here, the set in which counting ends, the set in which counting ends is called finite, If not, it is infinite. If not, it is infinite. Okay. So you just see here the set in which counting ends is called finite. So for example, you can also just see that is set of x such that x is lesser than or equal to 10, comma x belongs to natural numbers, Okay. So you can just see here x is lesser than or equal to 10 and x belongs to natural numbers. Here you can just see 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Counting ends, therefore it is finite. Suppose if I write x such that x is lesser than or equal to 10, comma x belongs to integers. So this is infinite. Okay, how it is going to be infinite? You just see lesser than 10 means, lesser than or equal to 10 means 10, 9, 8, 7, 6, 5 goes on like this, 0, minus 1, minus 2, minus 3, so on. Okay, so like this it goes on. So counting never ends here, no problem, it is going to be infinite, but you can just see here counting is going to be end, so therefore it is called finite set. Clear? So next you can see the set of months of a year is an example for finite set, no problem. Collection of planets. So see, collection of planets, you can say only what we all know, that you can tell, but there are still some more planets which we have not yet discovered. There are more planets which we have not yet discovered, yet to be discovered. That means I think planets, it is not that much of considerable example. Try to give another example. Clear? Okay. So now collection of stars, infinite, no problem. Okay. So next, fourth one, equivalent sets. Okay, you just see about equivalent sets, that is the set which has same number of elements, the set which has same number of elements, is called equivalent set. That means you can take set A equal to 1, 2, 3 and you can take set B equal to A comma B comma C. So see here, n of A is 3, n of B is 3. So I can tell that A is equivalent to B. A is equivalent to B. Clear? So here please understand, equivalent is different, equal sets are different. Equivalent means the number of elements in which it has same elements. Okay, that means in which the number of elements are same. In which the number of elements are same is called equivalent set. Okay, that means in the set A it has 3 elements, in the set B it has 3 elements, therefore both the set A and set B are equivalent sets. Clear? Now we shall go for equal sets. Now we can go for equal sets. Okay, equal sets means the set which has same number of elements as well as the elements also same. The number of elements and the elements itself are also same. Clear? So that means the set which has same elements, the set which has same elements. The set which has same elements means, here see, the number of elements also must be same, the number also must be same, and elements themselves also must be same. For example, you can take set A equal to 1, 2, 3 and set B equal to again 3, 2, 1. Okay, so see here, the elements are also same, the number of elements are also same. Therefore, here set A equal to set B. Set A equal to set B. Clear? You can also write it as A equal to B, C, A, and another set B you can write it as C, A, B. No problem. You can just see the elements inside the set are same as well as the number of elements are also same. So therefore we can call it as A equal to B. Clear? Okay, coming to subset and superset. Here you can just see, if every element of A is present in B, then A is subset of B. Also B is superset of A. That means every element of A must be in B. For example, A I will take it as 1, 2, B I will take it as 1, 2, 3, 4. Okay, so see, every element of A are present in B. That means A is subset of B. On the same way, B is called superset of A. A is subset of B, and B is called superset. of A. Clear? So therefore, from this you can tell that if every element of A is present in B, then A is called subset of B. Also we say B is superset of A. Okay, so if I write like this, here you just see, if I write like this, what it means, A is subset of B and B is superset of A. Clear? So from this you can understand that what is subset and what is superset. So quickly reply me, all of you, how many of you are following the classes and how many of you are understanding the concepts? Quickly tell me. If you have any doubts, quickly you have to ask. Okay, before going to the next concept, you have to ask. If you are following, no problem. If you have any doubts, you can ask. Okay, so subset and superset all are little bit very simple concepts, so that you can tell, no problem. Equal sets I think all of you can know it, no problem. Okay, next coming to proper subset. Coming to proper subset. See here, proper subset means A is called proper subset. A is called proper subset of B. A is called proper subset of B if B contains every element of A and also which has one minimum one element which is not in A, So see, this is how we have to understand the definition. This is not a regular way of writing the text. This is the way of understanding the concept. Okay, here I have not written the textbook language. I have written how we can understand the concept. Clear? So that you have to see. A is called proper subset of B if B contains every element of A, and also which has minimum one element which is not in A. What it means, you just see here. A has 1, 2, 3. B has 1, 2, 3, 4. Now you can tell that A is subset of B. Still more, you can say A is proper subset. A is proper subset of B. Why? Because you just see here, every element of A is present, and I have one element which is not in A. Therefore, A and B are called A is called proper subset of B. Okay. That you can also see, if A is 1, 2, 3, 4, B is 1, 2, 3, 4. Now I can't say A is proper subset of B. Why? Because both the set have same elements. Again, if I say A equal to empty and B equal to 1, 2, 3, 4, we know that empty set is subset of all set. See here, please remember one note. Empty set is subset of all the sets, but you can say that this is also not proper. Okay. So that means there are two improper subsets. Please remember, there are two improper subsets. One is empty and another one is set itself. Okay. These all concepts you must know. Clear? See, I am going to write some very important note for this subset, proper subset and improper subset. So please all of you go through it. Proper means you must have at least one element which is not in subset. Then we say that it is proper subset. For example, you can write it as, see here, A equal to 1, 2, 3 and B equal to 1, 2, 3, 4, 5. So A is proper subset of B. Then what are the improper? The improper sets are empty. Empty set and set itself are improper subsets. are improper subsets. Clear? So there are two improper subsets always. One is empty as well as set itself. Remaining all the subsets are called proper subsets. Remaining all the subsets are called proper subsets. Are you getting my point? Most of the time they ask in the exam, give me the number of proper subsets, give me the number of improper subsets, like that. So be very careful. Clear? Empty set and set itself are always improper subsets. Clear? Okay. And here you can also see one very important relation, that is natural number is subset of integers. Natural number is subset of integers. Natural number is subset of integers. Integer is subset of whole numbers. Whole numbers is subset of rational numbers. Rational number is a subset of real numbers. Rational number is subset of real numbers. Are you getting my point? So what is meaning of this? What is meaning of this? All naturals are present in integers. All integers, sorry, here all integers are not present in whole numbers. Sorry for this. All integers are not present in whole numbers. So here you just see this. Natural numbers are the subset of whole numbers. Whole numbers are the subset of integers. And integers are the subset of rationals. Rationals are subset of real numbers. Clear? So all the naturals are present in whole numbers. All the whole numbers are present in integers. All the integers are present in rational numbers. And all the rational numbers are present in real numbers. Clear? So therefore you can just see every natural is whole number. Every whole number is integer. Every integer is rational. Every rational is real. Are you getting my point? Therefore, you can tell that natural number is subset of whole number. Whole number is subset of integer. Integer is subset of rational. Rational is subset of real. Clear? So therefore, from this I think everyone have understood this relation. So quickly tell me, all of you, have you understood or not? If you have understood this relation, then we can continue. Otherwise, I will explain it again. Clear? Converse is not true. Converse is not true. For this statement, converse is not true. Yes, this is right. Converse is not true. Please remember that. That means every real cannot be rational. Every rational cannot be integer. Every integer cannot be whole. Every whole cannot be natural. Clear? Okay. So now we can go for comparability of sets. Now we can go for comparability of sets. Clear? So let us see what is comparability of two sets. What is comparability of two sets? Clear? So here comparability means you can just see, you have to compare the two sets. Let us take set A and set B. Let us take two sets A and B such that either A is subset of B, either A is subset of B, or B is subset of A. Either A is subset of B, or B is subset of A, or A equal to B, or A equal to B. Okay. So if the sets are present like this, we say we can compare them. We can compare A and B as A is subset of B. If B is subset of A, we can compare them. A equal to B, we can compare them. They are equal or not. Okay. So for example, if I take A equal to 1, 2, 3, A equal to 1, 2, 3, B equal to 4, 5, 6. Here A is subset of B or not? Quickly tell me. On the same way, B is subset of A or not? Quickly tell me. B is subset of A or not? Quickly tell me. A is equal or not equal to B? Quickly tell me. A is equal or not equal? Quickly tell me. Okay, quickly tell me answer for this. I have set A and B. So from this you can just see that A is 1, 2, 3, B is 4, 5, 6. So from this you can understand that now you have to answer these questions. A is subset of B or not? No. Very good. B is subset of A or not? No. Very good. A is not equal to B. Okay. So from this you can just see that these two sets are non-comparable, or you can say non-comparability of sets. You can say they are non-comparability of sets. Okay. So if you have to compare two sets, means either it must be subset or it must be equal. Either it may be subset or it must be equal. Okay. Then you can compare those two sets. Otherwise you can't compare them. That is what comparability of two sets. Clear? Okay, I think all of you have understood this. When we say comparable sets and when we say non-comparable sets, comparable means they has to be either subset or equal, then only we can compare. If they are not subset and not equal, we can't compare them. Clear? So therefore we say them as non-comparability of sets. Clear? Okay, universal set. See, universal set means it is according to the condition. It is according to the condition. Which type of condition? You just see. According to the condition. So here we say this is according to the condition. What is the condition here? The condition is, if I say A, B, C and D. See here, if D is superset of A, B and C, then we can tell D is universal set. Then D is universal set. Then D is universal set. Are you getting my point? See, then what is the meaning of universal set? Universal set means the set universal set is denoted by U. This U has to be the superset. U has to be the superset. U has to be the superset of all the given sets. Okay. If U is the superset of all the given sets, then this U is called superset of, then this U is called universal set of what? The given condition. Universal set of the given condition. Clear? For example, say here A equal to 1, 2, 3, B equal to 1, 2, C equal to 4, 5, D equal to 6, 7. Okay. Now I will write U as 1, 2, 3, 4, 5, 6, 7, 8. Now you can just see here, U is going to be the superset of all these sets. That means A is subset of U, B is subset of U, C is subset of U, D is subset of U. Okay. So according to this condition, now U is called the superset, or U is called the universal set. U is called the universal set for this particular condition. U is called the universal set for this particular condition. Clear? So quickly all of you tell me, have you understood this? If you have understood this, we can continue. Otherwise, I will clear your doubts, whatever you have. So then we can go for the next concepts. So every concepts must be clear. That is what our intention. Quickly give me the thumbs, give me smiles, anything. The answer must be positive. Clear? So some of you are worried about the exams, some of you are worried about the second year syllabus, some of you are asking so many number of questions. My dear students, I want to tell you one thing. Be ready for everything. If you read every day, if you prepare every day, if you are always in the ready position with every concept, we conduct the exam, you are in ready position. If we postpone the exam, then also you have to be in ready position. Okay, why you are worried that much? You read every day, you prepare every concept, and be ready for any type of exam. Clear? That means there will be no tension of exam dates, no tension of postponement of the exam dates. Why you are worried? If the notice comes, if they announce, then definitely there is going to be an exam. Okay, so please stop about worrying the dates of exam. What you have to do, you have to be ready position. You have to be in ready position at every time. It comes only with the regular studies. It comes only with consistency of performance. So who are very consistent with their performance, they are not worried about this type of things. Okay, prepare every day. If the dates comes, I will also tell, I will also announce. Okay, don't worry. So now let us go for power set. What is power set? That means it has full of power. So that's why it is called power set. Yes or no? Set which has full of power. The set which has full of power is called power set. Yes or no? Quickly tell me. This is joke. Okay, this is mathematical joke. Okay, power set means not which is full of power. In mathematics, power set means it has different meaning. Okay, the power set in mathematics, it has different meaning. Some of the students tell, sir, the set which has very much of power is called power set. The set which has no power is called no power set. Like that. That is not the way of mathematics. Okay, this is just the joke of mathematics. Okay, the set which has power is not called power set. Clear? The set in which all the subsets of the given set are present is called power set, or the collection of all the subsets. You see here, the collection of all the subsets is called power set, Okay, clear? So I think everyone knows this. Collection of all the subsets is called power set. That means if I give the set A equal to 1, 2, now you have to write all the possible subsets of A. Now you have to write all the possible subsets of A in one set. All the possible subsets of set A in one set. That is, first always we start with empty and set itself. First we always start with empty and set itself. Next we go for 1. Next we go for 2. So this is the power set. This is the power set of A. This is the power set of A. Clear? Next, if set A has 3 elements, what is the power set of A? Again, we start with empty. We write set itself. Next, we go for 1, 2, 3. Next, we write 1, 2. Next, we write 1, 3. And next, we write 2, 3. Okay. 1, 2, 1, 3 and 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is our power set. Clear? Yes. Empty set and set itself. empty set and set itself are always a subsets, are always a subsets of every set, are always a subsets of every set. Please remember this. Empty set and set itself are always a subset of every set. You take any set, empty set will be subset for it. Even for empty set also, if I write set A equal to empty, for this one of the power set is present, that is empty set. Okay. Clear? Or you can also write it as P of A as like this, no problem, because A is empty. Clear? So from this, I think all of you have understood the meaning of power set. Power set means the collection of all the subsets of the set is called power set. Okay. So everyone knows this. Everyone know this, but that is not important for us. What is important for us? The properties of power set. Now tell me, how many of you know the properties of power set? Very, very important. Properties. So many of you don't know the properties of power set, because this thing is very, very important. Okay. So see here, the properties of the power set are: first one, every element of the power set is also a set, This is first one. That means, what is meaning of this? Every element of a set, every element of a power set is also a set. For example, you say, I will take A equal to 1, 2. Now I want to write P of A. What I will write? I will write empty. I will write 1, 2. I will write 1. I will write 2. Okay. Clear? So now you just see every element of P of A. This is empty. This is set itself. This is singleton set 1. This is also singleton set 2. Okay. That means each and every element of a power set is also again a set. You have to remember this. Each and every element of a set is also again, each and every element of a power set is also again a set. Clear? That means you can just see here in this example, each and every elements are also in a set. Each and every elements are also in a set. Clear? Okay. Next we can go for the second property, that is, if A is subset of B, then power set of A is also a subset of B. If A is subset of B, then power set of A is subset of power set of B. Clear? That means if you take A and B are the two sets, take B as 1, 2, 3. Take B as 1, 2, 3. In the previous example we have taken here, you just see this is B and you take this as A. You write this as power of B. Okay. So now here A is subset of B, and you can also see that P of A is also subset of P of B. P of A is also a subset of P of B. That means power set of A is subset of power set of B. You can check empty, present, 1, 2, present, 1, it is also present, 2, it is also present. That means each and every element of P of A, is present in P of B. That means you can understand that if A is subset of B, then power set of A is also a subset of power set of B. Very important point. Okay, next we shall go for the next point, that is the power set of any set. The power set of any set is always non-empty. Always non-empty. Meaning of this is power set has minimum one element. Meaning of this is what? Power set has minimum one element. You can take any set. You take empty set. What is P of A? What is P of A? P of A will be equal to set of empty. Okay, because empty set itself also has to be written in power set. Clear? Otherwise you can write it like this, no problem. Okay, so power set is always non-empty. Please remember, power set is always non-empty. Clear? Okay, next we can go for fourth one. If A has n elements, if A has n elements, then power set of A is 2 to the power of n. That is, if set A has n elements, then the power set of A has 2 to the power of n elements. 2 to the power of n elements. Clear? This is very important. Power set of A has 2 to the power of n elements. Very important formula. I think all of you know this, no problem. Still they make you to get confused. Still they will confuse you in the exam by asking the questions in different manner. See, they can ask the question like this. If set A has 1, 2, what are or how many proper subsets are present? Proper subsets are present. They may ask you like this. See, this is the way of making you to get confused. You know set, you know subset, you know what is subset formula, you know what is proper subset, you know what is improper subset, and you know what is the formula for the total number of the subsets. Everything you will be knowing, but still you will make wrong this in your exam. See, most of you are giving it as 4. But 4 is not the correct answer. That's why I said they will make you to get confused. And you are definitely going to be confused. What they are asking? They are asking proper subsets. So see here, when you write P of A, these are your total number of subsets. In this, empty and set itself are called improper. Therefore, it has only 2 elements. So that's why I say definitely they will make you to get confused, and you are going to get confused. Clear? So that's why you remember here, the total number of the subsets is given by 2 to the power of n, and you can also write one formula here. The number of proper subsets is equal to 2 to the power of n minus 2. The total number of proper subsets is equal to 2 to the power of n minus 2. So here 4 minus 2 is 2. Clear? Okay. So I think you understood these 4 properties. Still there are Still there are some more important properties like see here, it is I think fifth one, okay. See the fifth one, P of A is subset of P of B. P of A is subset of P of B, that is equal to P of A intersection B. If power set of A intersection power set of B you do, you are going to get power set of A intersection B. And the sixth one you can see, power set of A union with power set of B will be subset of power set of A union B. Will be the subset of power set of A union B. Very, very important. Clear? Power set of A union with power set of B is a subset of power set of A union B. And the seventh one you can see, power set of A union with power set of B is not equal to power set of A union B. Is not equal to power set of A union B. Very, very important. Very, very important. Here the fourth one is also very, very important. Clear? So these are the some important properties of the power set where most of the students never study because they only focus on board exam preparation and they make wrong things. Clear? Okay, no problem. So now you just see these two very, very important. Power set of A intersection with power set of B is equal to power set of A intersection B. And see the sixth one, power set of A union with power set of B is a subset of power set of A union B. And the seventh one is power set of A union power set of B is not equal to power set of A union B. So try to understand them. When the examples come, I will explain it very much correctly or neatly. Clear? So first, for time being, you just understand it. Very, very important things. You remember like a formulas. No problem. So now here I have one problem. So let us go through this problem. You just see the problem. You just see this problem, that is, if set A has two finite sets. Two finite sets have m and n elements. Two finite sets have m and n elements respectively. M and n elements respectively. The total number of subsets. The total number of subsets of the set. The total number of the subsets of the first set is 56 more than the total number of subsets of the second set. Then what are the values of m and n respectively? Very nice question. Very, very nice question. I think all of you can answer this. So quickly tell me how many can answer this. How many of you can answer this for this particular question? See, there are two sets. Let us take A and B. Don't give answers blindly. You have to think and give. There are two sets A and B. Okay. Now what they are telling, there are m elements and n elements respectively. So let us take n of A is m and n of B is n. Okay. So now what is the condition? The total number of the subsets of the first set. That means the total number of the subsets in the set A is given by 2 to the power of n. The total number of the subsets of the first set is 56 more. That means if I subtract the total number of the subsets from the set A with the total number of the subsets in the set B, it will give me 56. Please understand this. Please understand this. There are two sets m and n elements. There are two sets m and n elements having m and n elements. Clear? So you can see here the total number of the subsets in the first set, that is P of A, power set of A, is having 56 more, that means plus 56 then in the power set of B. Clear? That means P of A, so here you can just see P of A minus P of B is going to be equal to 56. P of A minus P of B is going to be equal to 56. Clear? So that you can see here the total number of the subsets in A are 56 more than in the subsets B. Have you understood this? That means the total number of the subsets present in the set A minus the total number of the subsets present in B will give you 56. Will give you 56. So therefore now I can take 2 to the power of n as common. It will be 2 to the power of m minus n minus 1 equal to 56. Okay. And you can write it as 2 to the power of n, 2 to the power of m minus n minus 1 equal to 8 into 7. You can write it as 8 into 7. Now you just say 2 to the power of n into 2 to the power of m minus n minus 1 equal to 2 to the power of 3 into 2 to the power of 3 minus 1. 2 to the power of 3 minus 1. Clear? So from this I think you can understand, that is 8 is 2 to the power of 3, 7 is 2 to the power of 3 minus 1. 7 is 2 to the power of 3 minus 1. That means 8 minus 1. You can just go through this equation. Total number of the subsets in set A minus total number of the subsets in the set B is equal to 56. So now you can you can take 2 to the power of n common. If I take 2 to the power of n common, it will be 2 to the power of m minus n minus 1 equal to 56. You can just compare this as 2 to the power of n equal to 2 to the power of 3. 2 to the power of m minus n is equal to 2 to the power of what? 7. Okay. So that will be equal to, here n is equal to 2 to the power of n is equal to 2 to the power of 3. From this you can write 2 to the power of n is equal to 2 to the power of 3 by comparing component wise, or you can say by comparing LHS and RHS. By comparing LHS and RHS, 2 to the power of n is equal to 2 to the power of 3. Therefore n is equal to 3. Therefore n is equal to 3. On the same way you compare one more term, that is 2 to the power of m minus 1 equal to 2 to the power of 3 minus 1. Okay. This is 2 to the power of m minus n. See the second term, 2 to the power of m minus n minus 1, 2 to the power of m minus n minus 1 equal to 2 to the power of 3 minus 1. Minus 1 will get cancelled. 2 to the power of m minus n will be equal to 2 to the power of 3. M minus n will be equal to 3. Here you have n is equal to 3. You use here m minus 3 equal to 3. So from this m is going to be equal to 6. So you just say m is equal to 6, n is equal to 3. This is your answer. Okay. So with this you can see that our answer is 6, 3. Our answer is 6, 3. Clear? So most of you tell that answer is D, but D is not your answer. Your answer is B, that is 6, 3. Okay. So please go through this type of problems. Try to concentrate on the class. I think you can chat with your friends later about tea, coffee and all. You have to chat it before the class. Before the class you will have time of 5 minutes or 10 minutes. There you come and you chat about tea, coffee, breakfast, lunch, how are you, who are you, everyone. Okay. So when the class starts, who are you, how are you, where are you, all those things are not allowed. Don't waste the time. You have to concentrate on the class. You have to concentrate on the text. Okay. So don't do this type of things. Whenever you are in the class, you have to concentrate on the class. Clear? If you are still very much interested in chatting with your friends, you can go offline and you can chat with them, no problem. Otherwise you can chat before the class. Otherwise you can chat after the class. When the class starts, everyone has to concentrate on the class. I feel that is very good. Okay. So now quickly, properties of power set I have already discussed. Properties of power set already I have discussed. And coming to problem number 5. To just see problem number 5. Very important. Quickly try to give me the answers. Set A equal to 1, 3, 5. Set A equal to 1, 3, 5. So from this you can see that what is P of A? P of A is 2 to the power of 3. 2 to the power of 3 is 8. Now try to give me the answer. I will give you time. I will give you time for 1 minute. Try to give me the answer. What is your answer for this particular question? Try to give me very quickly. So now I want P of A. P of A. So what is P of A? Some of you are telling it as 8. Please read question carefully. They are asking P of A, not only P of A. You have to calculate power set 2 times. You have to calculate power set 2 times. Most of you giving the answer as 8. Most of you are giving answer as 8. I know, because most of you can give answer as 8. So they want that. So that's why they have given option 1 as 8. Here they have asked P of A, not only P of A. P of A means now you got 8. P of A is 8. P of A means 2 to the power of 8. You just calculate 2 to the power of 8. Okay. That means 2 into 2, 4. This is 5th, 6th, 7th, and this is 8th. Clear? 4, 4, 4, and 4. Here you see 16, 16. Multiply 16 into 16. So 16 into 16 means last term must be 6. So here you can just see only the one option is present with last element as 6. Therefore 256 as your answer. These all are your shortcuts. Clear? So you have to multiply 2 for 8 times. That means 2 into 2 is 4, 2 into 2 is 4, 2 into 2 is 4, 2 into 2 is 4. 4 into 4 is 16, 4 into 4 is 16. If you multiply 16 into 16, whatever be the digits here, the last term will be 6. So see here, in this 4 options, this all 3 I can delete because last option is not 6. Anyways, you will get 256. That is not big thing. But whenever you are answering, you have to use this type of techniques. Clear? So therefore 256 is your correct answer. Clear? Quickly, problem number 6. Solve problem number 6 and quickly tell me the answer. Quickly solve problem number 6 and tell me the answer. I am waiting for your answers. I will see how many can answer this. For problem number 6. Already I have discussed the properties. Already I have discussed the properties previously. So how many of you are concentrating on the class? They can give the answer. How many are concentrating on the class? They can give the answer. Who are not concentrating on the class? They can't give the answer for this, for problem number 6. See, When you know the concepts, you can solve them very quickly. In 1 minute, you can solve both the problems. Clear? So quickly tell me, already I have discussed these properties of power set. Okay. If you know, then you can answer it very clearly. If you know, you can answer it very clearly. Very good. Some of you are giving the right answer. Some of you are giving the wrong answer. Who are giving the wrong answer? They have not concentrated the class correctly. Okay. So properties of power set, I think I have cancelled it. No problem. So here you remember the properties of the power set, that is P of A union P of B is subset of P of A union B. Clear? And P of A union P of B is never equal to P of A union B. One more, P of A intersection P of B is equal to P of A intersection B. These things already we have studied. At least now you give me the answer for the properties of power set. For the properties of power set, at least now you give me the correct answer. I have written on the screen. At least now you can give the answer. Okay. See, if you don't concentrate, such simple questions also you can make wrong. Such simple questions also you can make wrong. So here, which option is right? See, P of A union B is equal to P of B. Check this. So this is not correct. P of A union equal to P of B. Check this. It is not correct. And check option A. P of A union B is not equal to P of A union B. Right. Okay. So therefore, there is no need of option D. So therefore, option A is the correct answer. Yes or no? P of A union B is not equal to P of A union P of B. P of A union B is not equal to P of A union P of B. Answer A is correct. Answer A is correct. So who all got the right answer? Congratulations. God bless you all. Who are not concentrating on the class, God will not do good for you. Please understand. Who are not concentrating on the class, God will not bless you. If you need the blessings of God, you have to concentrate on the class. Clear? If you not concentrate on the class, it is left to you. Okay. So therefore, we can continue in the next session with the Venn diagram, operations of sets. So I will continue them in the next class. So let us go with the synopsis of the sets in the next class. So let us continue with the synopsis. I think 1 or 2 classes, in coming 1 or 2 classes, I can cover all this synopsis of sets, and next we can go for MCQ type of questions. Okay. So before that, all of you please go through the videos of yesterday as well as today. Please make practice of all the things what I have explained. Go through all the synopsis points. Okay. So then only you can do good. Clear? Okay. I will share the notes. Don't worry. Good night. Take care. Bye.